What's up, you scholars of enlightenment? Welcome back to another live stream. It's a very, very exciting time in the world of asteroid deflection. It's all gone a little bit Armageddon. So it's time for DART, excuse me, the double asteroid redirection test, which is going to be happening in about half an hour. So I'm going to give you a few notes, a little bit of a breakdown of what it is, just a reminder. And then we're going to watch the live stream from NASA. So here we have a nice layout of what the DART mission is. Essentially, we have a spacecraft, DART, which is flying towards a double asteroid system, which explains the double asteroid name in DART. Didymos, the larger object, and Dimorphos, the smaller one. Now, Dimorphos orbits Didymos, the larger one, and has a particular period of its orbit and a particular distance, particular radius of its orbit. And this can all be observed from Earth because Dimorphos passes in front of Didymos, as we see from the Earth. It's essentially an eclipsing binary, and the amount of light we see from Didymos is therefore reduced. So if we have a roughly circular orbit, we can get an idea of the frequency of that orbit, the speed of that orbit, the size of that orbit from just looking at the eclipses of Didymos that are made by Dimorphos passing in front of it. Then what we're going to do is we're going to take a massive spaceship, DART. We're going to smash it into Dimorphos. And what we're going to do is try and deflect it slightly closer to its larger companion Didymos. And that will shorten the orbit in terms of time and make it a little bit closer to Didymos. So then if we look from ground-based telescopes and also from this CubeSat Lycia cube, which was ejected from DART, we should hopefully be able to see that the orbit of Dimorphos around Didymos has been pushed a little bit closer and a little bit faster, and we can see that in the nature of the eclipses before and after the impact of DART smashing into Dimorphos. And the idea of this is that essentially we'd be able to deflect with a kinetic impact an asteroid were it to become a danger to us here on Earth, were the asteroid to be coming towards us here on Earth. So very important to point out, there is no danger at the current time. Didymos, Dimorphos, they're not coming towards Earth. We're not going all deep impact. We don't have to run off to the middle of the country or get to high ground. We're entirely safe. But we want to know if, on the occasion that one of these things were coming towards Earth, would we be able to deflect it using a kinetic impact? And there's a few problems here, right? Because you have these huge asteroids potentially coming towards Earth, so you need a big impact to deflect them. Also, we're not entirely sure what the composition of these things are. So when it smashes into Dimorphos, is it just going to disappear in a ball of dust? Is it going to kind of merge into the surface and not really give it much of a push? We don't know much about the composition of these objects, and we don't know much about what will happen when we smash into it with a kinetic impactor. So that's the idea of trying to work out what's going on. And we're going to jump to the live stream soon. But that's the idea. Smash this spacecraft into the system. Try and see if we can deflect Dimorphos's orbit and see if we can detect how much of a deflection we've managed to achieve with the Lycia cube and from ground-based observations. So, as I say, this is the double asteroid redirection test launched in November 2021. So it's been flying for nearly 10 months, 11 months to get to its impact site, and in about 20 minutes, 25 minutes, it will smash into there and end its life and hopefully give us some very interesting science. So I think I've covered most of these things. Just to give you a little bit more information. So the system is comprised of these two asteroids, Didymos, which has a diameter of about 780 meters. So that's the larger of the two in the system. And the smaller moonlet, which is Dimorphos. Essentially, they're calling it a moon because it's orbiting the larger asteroid. And this one's about 160 meters across, so a fraction of the size, and orbits the larger asteroid. And the current orbital period is about 11 hours and 55 minutes, so about 12 hours. And the separation is just over a kilometer, 1.2 kilometers. So when the DART spacecraft smashes into this thing, We're hoping it'll be slowed down, deflected, and pushed a little bit closer, and we'll be able to measure that difference in timing and that deflection by looking from ground-based instruments. So that's the idea. I'm not exactly sure what we're going to see on this live stream, because are we going to see something from Lycia Cube? Are we going to see delayed transmission from DART? I'm not exactly sure. So we're going to jump over to that in a second. We will be joined by astronomer Jason Steffen, who's going to join us when he's finished with some of his students on the top of the hour. So let's jump over to that live stream now, and let's get up to date and see what we can see.
Could you
make sure we're on the latest timestamp?
Tom, could you expand a little bit more on how we will use this information in the future if all goes successfully?
Well, this test is really important to understand how we might be able to deflect asteroids in the future. And when we measure the change in the binary period of Dimorphos,
yeah, omniferous. If it's a ball of dust and it just sort of disappears into it, it's going to be a little bit of an anticlimax.
And then as we get deeper understanding into exactly what the geology was of that asteroid, that's the basic information that's going to help us refine our physics understanding of asteroids and our ability to compute and predict, like Dawn does, run these fantastic codes and extend this knowledge to really have a good plan for how we might react if we ever do discover a dangerous asteroid that is different from Dimorphos.
On there.
Well, hey, I mean, it's better to be safe than sorry. So it sounds like y'all's party is really just getting started after impact. So congratulations on your success so far. It has been a pleasure. Thank you so much. Now, any second, we should be learning if DART has a precision lock on its target Dimorphos. This is a key milestone critical to tonight success. Samson, mission operations must be buzzing. How are things going?
We need to check that.
Hey, Tahira. The energy is indeed electric, and the team is hyper-focused. You could hear a pin drop right now as we're coming up on the critical 20-minute mark from impact and expecting to hear from the team that SmartNav is now precision-locked onto Dimorphos, which means that SmartNav will be tracking only Dimorphos from here on out. Why? SmartNav has full confidence that we're in fact tracking Dimorphos, and so we want to remove any confusion by continuing to track Didymos. Because what could happen with Didymos is that its shape could be such that there's a lot of shadowing, which could make it seem in the Draco imagery like multiple blobs, as the team likes to call them.
That's interesting.
And we don't want SmartNav to mistake any of those blobs for Dimorphos, so we're doing away with tracking Didymos altogether. We are waiting for that announcement
get a little bit confused,
of precision lock.
Not exactly know where they're aiming towards and could lose lock. So
actually, we have some time until we hear that.
So they're just trying to make sure that isn't the case, and it can get a nice smooth lock on where it's going to go and bury itself. Very interesting. So it seemed like they were saying if there's a kind of shadow down the middle, bright on either side, it could get confused. Which one am I aiming towards? Am I aiming for this body? Am I aiming for this body? When they're really one body joined together with a shadow down the middle.
Precision lock.
So they're looking for that lock.
All right, we expect to be in precision lock soon.
"20 minutes to go." Very exciting. Jason should also be joining us very soon, so we'll get his thoughts as well as an astronomer. Lots of static on their on the NASA webcast. That isn't on my end, I promise. It's raising the tension.
We are waiting for confirmation of precision lock.
So again, the camera's just trying to get that full lock onto the place it's going to go and smash into on.
MSC, this is SN5.
Go ahead, SN5.
We are precision locked and still tracking Dimorphos.
Yes.
Excellent. So that's another hurdle passed. Locked onto where it's going to smash into.
We are soon going to hear again from Elena Adams.
This is great. This is DART MSC on DT Mach. So this was our last milestone. At this point, we're going to be working towards Dimorphos. I expect we're going to do some burns. We're about 4,500 miles away from Didymos and Dimorphos, so let's see what happens.
Anyone ever play that game Asteroids when they were a kid?
Right, joining me now to react to that bit of good news is Lindley Johnson, NASA's Planetary Defense Officer. Lindley, you heard Lena, we are now precision locked, a lot of applause, things are looking good. And we are now headed for the moment of truth. How are you holding up?
Oh, I'm doing great. The team's been doing great. The spacecraft's doing great. This precision lock, is absolute milestone for the terminal phase here. We've got a good signature on Dimorphos, so the spacecraft has what it needs to guide itself in for the impact here in 17, almost 18 minutes. So we're doing great.
Yep, so close. Very exciting moments ahead. Now, we can't say this enough, and I know you've said it so many times, but it's worth repeating for viewers that Dimorphos is not a threat to Earth, nor will it be after impact, right?
No, that's right. This asteroid system is still almost 7 million miles away from the Earth. It's at its closest point in the orbit right now to Earth. So from this point forward, it's going to be moving away from Earth. So there's no chance of anything here. We've got to look for all the other unknown asteroids out there still.
Awesome.
To find what the
so this is a big problem.
Thanks
that we
so
don't
much,
obviously track
I'll catch you
all
on
of these
the other
objects,
side of impact.
and we need to be ready
if you can.
One turns up out of the blue.
Back to you, Tahira.
All right, thanks, Samson. It is amazing to know that we have a precision lock on target Dimorphos. Now, we have a fun way for you to join our mission, and it is by signing up to be a planetary defender. Visit bity.com/planetary defender. Take the quiz and receive a certificate like this one. Now, once it's official, show us on social media using the hashtag planetary defender.
I might have done this.
Now, telescopes from around the world are observing tonight's impact to ensure that how successful we are at changing the asteroid's orbit. They'll be measuring this success. And you may be wondering, how does that happen? Let's go behind the scenes with astronomer Nick Moskovitz at Lowell Observatory, home to the telescope that discovered Pluto, to see what's in store for DART.
So like we said, a lot of ground-based measurements so that we can
This is Lowell
quantify
Observatory. Lowell is one of
what
many
the impact
observatories
does to
around
this
the world
binary
that will be
eclipsing
observing
system.
the DART impact, NASA's first ever planetary defense test mission to see how much a spacecraft impact can deflect an asteroid in its orbit. This is where Pluto was discovered, and we are still doing research in all areas of astronomy today. So let's go check it out. This is the Pluto telescope, the telescope that was used to discover Pluto almost 100 years ago. So here we are at the Clark telescope. This is where Percival Lowell sat to observe Mars. Let's head on over to the Lowell Discovery Telescope about an hour south of Flagstaff, which is where we are going to be collecting data for the DART mission. And the reason we're all the way out here in the middle of this forest is that we have really dark skies here. And this is the Lowell Discovery Telescope. This is what a 4.3 meter telescope looks like. This is what we will be using to study Didymos and Dimorphos in the days and weeks after DART impact. The DART spacecraft will be hitting an asteroid called Dimorphos. So special because it's a binary asteroid, which means a satellite around a larger asteroid called Didymos. And DART will actually be hitting Dimorphos. And what we will be measuring is how much DART changes the orbit of Dimorphos around Didymos. So this is an important test for planetary defense mitigation strategies in case we ever have to do this for real. The Lowell Discovery Telescope is one of many telescopes around the world which will be used to study Didymos and Dimorphos. It's really a global coordinated effort. And what we're looking at here is a large 4.3 meter primary mirror that's in the middle of the telescope tube here. Up at the top is a secondary mirror. The secondary mirror up top there is what is focusing the light down onto the instruments and allows us to take images with the camera that's located down at the bottom. This is maybe one of my favorite hidden rooms at the telescope. We're like standing inside the telescope, underneath the telescope, 100 tons above your head, held up by this and this, which is cool. It's sort of, as you can see, the highest peak around here, just over 8,000 feet.
Less than 15
Come up here for sunset. It's, you know, sun setting right there. It's perfect. For DART, we're going to be collecting images of the night sky.
Sorry,
typically, an observer would be here in front of one of these consoles, controlling the instrument, and taking images like these as they're coming in off the telescope. DART is really a sort of before and after experiment. We need to understand the system before the spacecraft intentionally impacts, and then we have to understand what the outcome of that impact event is. As we watch from the Earth, Dimorphos will pass in front of Didymos and behind Didymos. What we will be doing with those images is measuring the brightness of Didymos in those images and looking at how that brightness changes. And those dips in brightness allow us to measure when these eclipses happen and measure the orbit period of Dimorphos. And so you have essentially a fixed star field here. All the white dots are stars of different brightness, and moving through this field is Didymos and Dimorphos, which again, we can't distinguish them as discrete points of light, but we have that small object moving through the field of view. So after impact, we will then be able to go back and start observing intensely, looking for those mutual events, those eclipse events of Dimorphos passing in front of and behind Didymos. And on each one of these frames, we're measuring the brightness to assess whether or not it's undergoing one of these events where Dimorphos is passing in front of or behind.
So
and using those to determine the orbit period of Dimorphos around Didymos. This is such a cool experiment. It's such a singular experiment. Using the ground-based telescopes like this one and others around the world to watch the system and see how it's affected by this impact event. Because that's really what's going to give us the answer to what did DART do at the time of impact. And that will be exciting to see how that evolves over the days and weeks following that impact.
All right. After a 10-month, 470 million mile journey, DART is just minutes away from making history. A truly global effort. This mission has brought together people from around the world, united under one goal: to find a way to protect humanity from a hazardous asteroid if one were ever discovered. Now, usually NASA spacecraft are intended to operate for many years or even decades, but not DART. DART was built to be destroyed. DART is a mission of firsts, proving that a spacecraft can autonomously seek, find, and approach a target in space that's so far away we don't even know what it looks like. It also marks the first time humanity will have moved a planetary body in the universe. I said that correctly. Now, at this point, the spacecraft is controlling itself, making small maneuvers to ensure it's lined up with its target. DART is speeding through space and will cover the last 4 miles of its journey in just 1 second. Coming up, we'll hear the final updates from mission operators and witness the big moment live from space. Samson, you have the best seat in the house. How are we looking?
You're right, Tahira. Front row tickets to the biggest event in town, and things are looking good. We are T-minus 10 minutes to impact, and DART is precision locked onto Dimorphos and zooming down the home stretch. Now, we have a lot to cover in the time we have left, and I'm thrilled to have with me Lori Glaze, Director of NASA's Planetary Science Division, with me for the ride. Lori, such a pleasure to have you.
Oh my gosh, I am so excited to be here and really happy that we are here in this final 10 minutes. We are almost there.
Well, you were just in the thick of it
Jason has just
with
arrived,
the team up until a few minutes ago. What is the atmosphere like there? I can only imagine.
It's really, it's great. I mean, they're excited.
I'm going to pause it for one moment while I get Jason in here. Jason, can you hear me?
Yeah, let me...
I'm going to try and get you in here without it messing up. Not that one. There you are. Right. Have you got the stream? I can send you the link.
Okay.
I'll send you the link now. 1 second, guys, and we will
be... a really shiny forehead, don't
I? Don't worry about it. We will be back with the stream very shortly. I'll just send this to Jason. Unprofessional. I should have sent it earlier. So if you watch along with this just live, we can both watch. I've sent you it on Gmail.
There's a marker that we meet a milestone. Everyone is cheering. I'm very excited.
And I'm
after launch
up to live.
And they've been juggling a lot. Is there anything in particular that they are glued on as we enter this moment of truth?
Yeah, so the main thing they've been watching is...
Any thoughts from you on this, Jason?
Where we could do the precision lock.
It's going to be great. What are we looking at?
Good enough.
So we are looking at the Draco camera feed.
Where we are relative to
now
Dimorphos,
precision
that we
locked
could
on
really
Dimorphos,
do that precision lock onto the target.
Down the home straight,
hands
as
off
it were,
now, right? We're not, you know, the spacecraft is going to drive itself, and really focused on that, you know, that point where they could be precision
What's
locked.
happening today?
And they're also thinking about looking at reassessing continuously what's the probability of miss, right? As you get closer and closer, that probability should get smaller and smaller, and it is. It's getting, it looks really, really good right now.
It sounds like the game of thinking of wondering really doesn't end until that last second comes to pass. So they can do a lot of great up until this point.
Into a comet and speed a bunch of stuff out. And then they
well,
repurposed that satellite to get
all the years of thinking of doing planning
to look at exoplanets, which is of course the most important thing that
from 5 minutes
satellite
to impact, there will be no more
was looking at exoplanets.
So I was just explaining how this mission is very much like or has a lot of aspects of a kind of measuring transits of an exoplanet. So this system is an eclipsing binary, so you have the larger one, Didymos, and the smaller one, Dimorphos, which passes in front of it.
Yeah, it is. I mean, you can imagine.
Obviously, before and after, you can measure the frequency of those eclipses and get an idea and quantify how much of a deflection you've been able to achieve.
This team has been working
it brings in those nice
so
aspects of the kind of exoplanet work as well that people are
energy and their time into this, and so much planning and rehearsing. And
mass of these different objects?
It's a really big event for them to,
mass of these objects.
Counting down and watching. At this point, there's not much else they can do but watch and see the fruits of all their work.
Yeah, I have gotten to know many members of this team over the past few months, and
5 billion kilograms is Dimorphos, the asteroid.
You need a good mix of
and that's the small one?
To make sure we get
that's
to
the smaller
point.
One. And then half a ton, 570 kilograms.
Perhaps, like you said, a little
so
bit of
570 plays 5 billion. So what have we got there? 10 to the 9 and 10 to the 2, so 10 to the 7 between them. So
100 million.
Yeah, but I think they're ready. I think
10 million.
They're at that
10
point,
million
you know,
times.
You're getting some shots of Elena Adams, the systems engineer, and you can see the excitement
it's classified
in her
as
voice.
both a potentially hazardous asteroid and a near-Earth object because those are kind of synonymous, aren't they?
So they keep going at lengths and being at pains to point out that this thing will not come anywhere close to Earth now.
And we're not going to be making a black hole with it either.
Right. So another really interesting thing about this, which I briefly discussed, was we don't really know the constraight and composition of this thing.
Yeah.
So it could just smash straight through a big ball of dust, or just go straight into the surface. A little bit boring, but we'll have to see.
Remember, at this point, 5 minutes out, no more commands to SmartNav.
Discovered in 1996.
The team is watching it just like you and me and the rest of us.
So 5 minutes to go. 5 minutes 20. So it's really coming in on this thing now. We can see the two. You got Didymos, you got Dimorphos.
Let's see, orbit.
All right, we've reached 5 minutes from impact. The final command opportunity to SmartNav has passed, and the team is simply watching the data stream in just like we are.
So they can't stop it now, apparently. That's it.
Also remember,
Draco's in charge now.
38-second lag.
So it has probably some
Earth, and also an additional
AI
few more seconds for
style.
image
yeah, so Draco is like an AI tracker that keeps updating now. So it's been guided before now, but now it's not guided. And all the onboard electronics are dealing with
chatter in the mission.
Yeah, so they had
momentarily.
When they did the deep impact mission,
this is Dart
they basically had to
5 minutes till impact.
steer towards the brightest part the whole time. Like, whatever happens, go to the bright, walk towards the light.
So they just mentioned when they were trying to get the lock, one of the big problems they have is because they weren't too sure of the surface geometry.
Also, our window for
if you had a very shadowed part
done.
in the middle and 2 bright spots on the side, like a kind of dumbbell setup, then it could confuse the tracking algorithm, because it could be well, why are there two different objects?
Right.
I'm not really sure where to go. But apparently that's proved not to be a problem because, as you say, it's probably just zooming in on the brightest part of this.
I'm honing in looking at these images as we get closer and closer, and you look at Didymos and just
it's got to be going in fast if this is the
physical
resolution
body
of the
appear
image
there. It's incredible.
So we're starting to get surface features now for the larger one.
Coming in near real time.
It's got a weird.
Yeah, but you've been watching it over the last, 30, 45 minutes go from just being a collection of individual pixels, and
I
now
failed
you
to
can
do the
actually
maths, but
see
apparently
the shape and
it's
the
40 seconds delay, so it's not
texture
particularly
of Didymos,
significant.
and we're going to see that same thing with Dimorphos as we get closer and closer. This is so cool.
Never before seen images of Dimorphos.
So it's probably actually going to smash into it in 2.5 minutes, but we'll see it in 3 minutes.
Didymos is amazing. All right.
Yeah, it does have a weird.
The team is standing, just recognizing this moment, years in the making.
Is this when we find out that Avi was right, and it's just some little spaceship that's sat there doing nothing?
And just
hey, you never know.
This moment that's coming.
Yeah, and they've
artist
earned
impression
this,
of the dark spacecraft.
It's just great to see them there. This is so cool.
Lori, we hit another major milestone. We are now 2.5 minutes from impact. The SmartNav has stopped maneuvering the spacecraft.
Starting to see
Start is now coasting
shadows and structure on Dimorphos as well.
The history books.
Absolutely. This will be, I'm sure you've heard it many times tonight, humanity's first ever attempt.
I'm just waiting for it to fly
move
straight
another
past Jason,
body.
to be honest.
And also our first attempt ever to execute a mission sole purpose of planetary defense.
I guess eventually the large one will
go
completely out of the field of view, and you'll just
and I'm starting to see
Dimorphos
start to come into view there. You can see it starting to take shape.
Is going to start to go out of the picture as we get closer and closer.
Unbelievable clarity of images there.
Coasting on in, our projected miss distance is going to be about 17 meters.
All right.
Okay, so they're only going to miss by 17 meters, which is not too bad on something, half a kilometer across, I guess.
All eyes on this event. Space
missed
telescopes,
target
ground
spot.
telescopes from
I think
every
missed
continent
the very middle, the target destination.
All right.
Oh, so that they're estimating now what they're going to miss by.
I think so.
Like one single rock to me.
Oh boy, we're getting close.
14,000 miles per hour.
1 minute, here we go.
14,000 miles per hour.
14,000 miles per hour. Here we go.
45 minutes ago, 55 minutes ago, we couldn't even resolve this object in space.
Been traveling for nearly a year for this moment.
Zeroing in,
smashing
right
into this rock.
And we're now dropping the clock, and we'll go by loss of signal.
It's great to be alive.
Impact.
Certainly is.
There might not be electricity in Germany or Belgium.
Imagine we'll get that loss of signal, and we'll hear from Lena Adams again. And letting us know that we've been successful.
I feel like that'll be a crystal clear signal.
I think so. I think we're starting to see more resolution. In fact, look at that. Didymos has even gone out of the view. We're now just seeing Dimorphos.
Are they doing any observations?
This is remarkable.
Like, is there another orbiter?
There's a Lycia CubeSat which is watching close by.
Oh my goodness! Look at that.
So we might get some
control
more
system
afterwards.
settling down. Angular rates look really good. I think we're going to get the investigation team some good pictures.
Wow, we're seeing the surface features now.
Wow.
It looks like a dragon fruit.
No,
it does.
I was
just going to say.
Do better than that.
Starting to see those individual boulders there. You can see shadows of the various rocks on the surface.
Oh, look.
30 seconds, here we go.
Guys. Oh my goodness, look at that. Unbelievable.
Made out of monster.
Yeah.
It looks weird, doesn't it? Here we go.
Looks to me like we're headed straight in.
Yeah, I wonder where all those protrusions came from. I mean, that makes it seem like it's a rubble pile.
It does, doesn't it? Looks like it'll go straight in.
Instead of a solid object.
Yeah.
Oh my gosh. Oh wow.
Here we go.
Yeah. Oh my goodness. 8, 7, 6, 5, 4, 3.
Here we go. It's going to fill the screen, and then we're done.
1.
That's pretty cool.
Oh my gosh.
That rock.
Oh wow.
Cheering.
Awaiting visual confirmation.
All right.
Hope nothing's alive down there.
Let's see. We got it? Waiting.
And we have impact.
Thanks for tuning in, everyone.
Humanity in the name of planetary defense.
Woo. Fantastic. Oh,
that was pretty cool, actually. I'm not gonna lie, that was pretty cool.
How big is the size of that thing?
Beautiful to watch.
So the size of the smaller object?
Yeah.
About 500 meters across.
500 meters. Okay, so we were looking at rocks that were about a meter in size.
What a team. What a team and what an accomplishment.
Team. A few weeks ago, they had their last dress rehearsal.
But it did seem
they were
very
getting emotional at the dress rehearsal. They're like, "This is
very
This
fragmented.
is crazy. We're
It
getting
didn't seem
emotional.
like
This is not the real thing. You can only imagine what
it looked
they're
like
feeling right now."
like boulders with sort of sand in between.
Yeah.
Well, you can see
that makes me
there
think
on
it's a
screen.
rubble
They're
pile,
all pretty
probably
excited.
formed.
Wow.
Given the mass ratio, because so with
Hearing
asteroid
impact, the
moons,
curtains
if the
close
asteroid
on
moons are
Draco
similar
feed.
in
That raw joy
mass
from the
to the
team,
main
years of
body,
hard work and the weight of
those ones
expectation
typically
lifted
form
off
from
their
tidal
shoulders.
disruption.
This
So it'll
is
pass
amazing.
close by a planet or something like that, and it will spread apart and fission. But if the mass ratio is really large, then those typically are like collision fragments or collision debris.
Lori, really.
Because you'd think it might be so they get captured later. Because you think they kind of fuse together, wouldn't you?
Absolutely. Now, as I always say, it's one of my favorite
So do you think
missions.
the big one
Now
probably
is when the
caught it
science
later
starts.
on? Or?
It just starts
No,
now,
it
now
probably
that we've,
collided with something
impacted.
and that
Now we're going to
produced
see for
the-
real how
like a chip off
effective we
the
were.
original
We're gonna
body.
Train all of those
kind of like how the
ground-based
moon formed.
telescopes on the
that one guy
Didymos
look like Mr.
dimorphous
Burns to
system,
you?
and we're going to make measurements that will help us determine just what its orbit looks like now relative to what it was before. So it's going to be great. Very cool.
So this is when science, engineering, and
so I don't know.
A great purpose, planetary.
They're going to tell us now, I
together,
guess,
and,
what else we're going to see because we might not see much more tonight.
Yeah.
Really.
But that was fun.
So many people there that have made this happen. The team of APL engineers that have really
So they're running it out of Johns Hopkins.
poured their souls into this mission.
So the APL is one of the big laboratories. It's not as famous as JPL, but there's a lot of stuff that gets.
I thought Johns Hopkins was like a medical center.
A new
it's a university
of humankind.
and they would claim that they're the oldest university in the United States.
Potentially have the capability.
And why would
Harvard,
they
protect
that sounds like you're saying that
from
they would be
something
wrong
like
to
a
claim
dangerous, hazardous.
Well,
impact.
so it depends
What an
on what
amazing
the
thing.
definition
We've
of the
never
word
had that
is.
capability before.
Thank you so much, Lori. Those
Depends
are
on
poignant
how you
last
define
words.
what a university is.
Tahira,
So Johns Hopkins
history
was the
has
first
been
university that
made.
was
Back
built
to you.
around research instead of teaching.
Okay.
Wow.
And so it's at least in the United States. So that was the first German model
team. And
research
in case you're
institution
keeping score, humanity won.
where Harvard was
zero.
always
Now,
been
I'm
a
here
teaching
with Nancy
college.
Chabot,
Well,
Dark
it always
Coordination
had
Lead.
teaching as a
Nancy,
major component of
talk
its
about a moment to catch
thing.
on camera. What is going through your head
Just
right now?
just going to answer a couple of the comments.
thinking,
So,
wow,
will there be a
that's
large
amazing.
dust
Look
cloud?
at it.
Well,
I mean, those images
I guess we didn't
just
get
got
to see
closer
that
and closer,
because
and sort
the
of
thing
been
got
waiting
smashed.
for this moment. We've been
So
talking
once
about
we
it
see
for
from
years. At
the
APL
images
server
from
working on
Lycia
it since
Cube, hopefully we will
2015.
get to see something
I've been talking about
something like that.
They're going to be spectacular, and I think even then they exceeded my expectations of just zooming in like that. And it really is just such the team accomplishment, and to get to this.
It's interesting to me how everyone wants to put everything in terms of our reference frame, even though it's not all clear to me that you can even think of things in that way. I mean, we're very Earth-centric.
We did this.
As a general
Nancy,
point.
do you have anything you'd like to say to the teams who made tonight possible? Oh, I mean, I don't need to say anything
But we're
to the teams because I know
the planet with all the
like
smart people on it.
is
So
really proud to be part of this, right? Proud of this thing that we've been working on for years, And even
Somebody says,
2015,
I'm sorry, Laurie, I'm
internationally,
afraid I
people
can't
wanted
do
to
that.
this.
My
People
mission
wanted
has
to take this
changed.
first step.
I will land on
And then we
Dimorphos,
finally
gather the
did. First off,
microbes
United
detected
States,
by my
we have
scanners,
actually,
return to
20
Earth and
represented
release
on
them
our
into the
investigation team of
atmosphere.
scientists, telescopes on
Yeah, it
all
would have been
everybody doing their part.
it would have been
to make
interesting
this
if we'd have
moment
turned up to it and
happen.
it was, like I said, it was
I
just
know
a little
I'm,
spaceship sat
I'm
there.
really
But
honored to be on this.
I didn't see any
I know
spaceships.
no, like
I
Jason
didn't-
said, it looked
or-
like a rubble pile. So
And I was looking for deer or other kinds of
And so now that we have confirmed impact,
mountain goats or something like that, and didn't see any of those either. It
Omnif-
looked a lot like southern Nevada, just gray.
It did. It looked like your area of the world. So Omnifarious says all the kinetic energy was probably delivered to one small rock that shot out into space on the other side much faster than the spacecraft, which I guess would be possible. It could have just punched a little hole and thrown something very fast out.
Now we have like the jelly donut
shape? What does that mean?
Exactly. Possible, I guess. Bill Nye's there, apparently.
Their close approach, taking images,
hanging
and
around,
storing them, and we'll get those in the next days. Telescopes here and in space are looking. They're looking at the brightening of the rock that's thrown off from that spectacular collision that we saw. And this is going to go on for weeks. And so there's still a lot of excitement to come, but nothing to take away from this moment.
Yeah, this is just the beginning. It looks like everybody is celebrating here in Mission Operations. So I think I just saw Bill Nye there.
Find out if we're going to see anything more tonight.
It is a huge day for this team, but also for humanity.
We do need
Nancy,
space
you
goats.
mentioned earlier about some of the international collaborations. And could you give us an idea on kind of the scope of DART's mission, right? It's not just us in the United States that's focusing on this. So can you expand a little on that?
The surface looked with all those
defense is
rocks
really
and
an
stuff,
international issue. We are
like
all on this planet
out.
together,
So,
right?
Yeah.
Okay,
so
it's
I
500.
Think it's been so great for this mission to really support.
You said what?
And
It's 500 meters across?
500 meters across.
Planetary,
Okay, 500 meters across. So that means that some of those rocks, like as we were looking at it from a distance, the dragon fruit looked. Those were about
international scientists talking to each other.
Does that mean they were like 50 meters tall?
To make this moment
Could you fit 100 of them across? Yeah, that's about right. So they were 50 meters.
That'd be 10. So 5
but really, scientists around the world are ready to study the, what did we do to Dimorphos? But more importantly, what does that mean for potentially applying this in the future?
Yeah, okay.
I mean, DART really
5 meters. So you have these 5 meter
It's
sized
just the first
boulders were
planetary
the
defense test mission.
big ones.
It was spectacular. And
What does that tell you about
how effective it was? That's really what we're going to learn in the next
well,
weeks
one,
to
how
come.
this formed.
All right, we hit this asteroid. Now, how effective
And when
was
things
that
collide,
at
how they break
deflecting it,
apart.
and what
If
would
it
that
formed
mean
from a
for
collision
using it?
fragment,
Yeah, there's still
then
so much to
when that thing
unpackage
collided,
here.
because it's
And
not like
so
there's
we have a
any
special
geology
guest
on that
who
object.
I mean,
is
it seemed
wondering,
oddly
more of
lumpy,
what's
didn't it?
next for this big mission. So let's hear from her now.
And so when you
Hey everyone,
smash
I'm
into
Danny Hansen, American
a
rower and hydro athlete. And first, I would like to
an
congratulate
asteroid,
the entire DART team on
it looks like you produce a bunch of 1 to 50 meter sized boulders. And then what's going to happen is, so normally the skinny stuff would sink to the middle, like the small pieces would sink to the middle. So
this is a double asteroid system. So all we've done here actually is,
you know, because so if you have a bucket of sand and you put marbles in it.
Sorry. The correction. That's right. So it's 500 meters for Didymos and only 160 for Dimorphos. Thank you for the correction, GA. That's
160 for okay, so they're like a meter size.
Yeah.
So that means that those
like
little boulders were actually like a half a meter size.
Something like that. Yes.
So I wonder if that says that's how big the debris fragments are that come off of something. So because the largest stuff would rise to the surface. If you have a collection of material and it's shaking for some reason, the skinny stuff will sink down to the middle and the bigger stuff will float to the surface.
Thanks, Tahira. I have the pleasure of...
So how are you? So is that changing your idea of how you think this thing might have been
Well,
formed?
so that might explain why they were so big sticking out of the top.
Yeah.
Like why it looked like a dragon fruit instead of a marble.
So what came to mind with me was when they did the impact for I'm gonna have to remember the name of the mission now, but they went to Bennu, right? And they did the is that Osiris Rex, right? Osiris Rex. And
where they like scooped up a bunch of stuff.
They went to scoop up, so they pushed into the surface and very quickly sort of basically just captured like a hockey puck type amount before it pushed away the asteroid and bounced back off essentially. But what
they got so much that
they found with that they got so much regolith and it was so diffuse and sandy and gritty that they got so much they couldn't even like close the hockey puck type capsule. So it's on its way back now, and they think bits are going to be leaking out all over the place. I think they managed to close it in the end, but they got so much regolith because this thing was so bitty. Now
fluffy.
Yeah, obviously that's an n=1 thing, but that one also looked pretty gritty and.
Yeah, well, so they do weather. Like micrometeorite erosion is usually how these weather, which means that the sand is actually shards, like shattered pieces of the material. So it's a lot more gritty than what you get at the beach.
And to see the team.
Don't want to be doing much sunbathing there on Dimorphos.
What does this mean for NASA? What does this mean for Planet?
Is this the guy you said looks like Mr. Burns? He looks a bit more like Fauci to me.
No, that's not the same guy.
So for us, it's the ultimate fulfillment of our mission.
The guy that looked like Mr. Burns was wearing a suit.
Demonstration that who knows someday could save our home.
What's your take on these kinetic impactors? What do you think we would, if we saw an asteroid coming towards the Earth tomorrow, Armageddon style?
Mm-hmm.
What are we looking at? Nukes?
Depends. How much time do we have? Do we have 10,000 years?
No. Let's call it a year like this.
Oh. Then we all like hold hands.
Is it pray? All right. Okay. What time scale would we have something that we could actually action? Or what would it be?
I think a century would give us enough time to do something.
But that's basically what we're talking about with this, right? We're talking about a long period thing where we've got years or longer to hit this thing with a kinetic impact, change it by a small amount, and then over the period of many orbits or massive motions through space, the deflection is going to be turned into a large translation. So if you have a small deflection, but that's obviously projected out to a large distance, that becomes a large deflection at the end of that arm. So I think that's the idea we've got here: is tiny deflections done early enough give huge deflections projected, onto the plane of the Earth.
Yeah, well, and a lot of that can just arise from the chaos in the solar system. So when they do simulations at like what's going to happen in the future of the solar system, we don't actually know where the solar system objects are going to be. Okay, so that's 100 meters across. So we're actually like the smallest objects that we're seeing there
probably like a few inches or something,
bowling ball sized. Yeah. But let's see, what was I saying? So I got distracted by the dragon fruit.
It's all right. You get another image here if you want to have a look.
There it comes.
So we're getting some cool replays now. So we've got the dragon fruit coming in. So those bigger ones probably like a couple of meters, and then these smaller ones a few inches.
Yeah. So I was saying something, I'm sure it was really profound, but that we'll just leave that out in the ether.
So Omniferous says, aren't the rubble piles all regolith? Which I think is maybe basically what you were saying, right? It's kind of small regolith down to the middle, and then these
I suspect that this probably
is there a core in the middle.
I don't think there's a core. I suspect that it might be chondritic, though, so it might not have differentiated at all. So they're uniform composition.
So if you were to rip off half of it, it would just look the same underneath.
Right. You may get a size distribution as you go deeper. Okay, so I think what I was saying before had to do with...
Omniferous wants to use a gravity tractor. I'm not sure what a gravity tractor is. Obviously, it's going to use gravity.
Oh, where you like... Oh, okay, so that's what I was going to say. So when they do simulations to see how stable the solar system is, how long do we have to live before Mercury smashes into the Earth? They will displace Mercury by the width of a thumbnail, like the skinny width of a thumbnail.
Right.
And get a totally different result a billion years into the future.
Just because of the chaotic... So like a butterfly flaps its wings in New York kind of idea.
Yeah. And so you can't... we can't look at an asteroid and say, this one's definitely going to collide with us sometime in the next...
Yeah.
We can say something probably out to about 50,000 years.
Yeah.
But not much beyond that. And so... I think if we were going to see something, 1,000 years would be fairly easy, I think, to do it. 10,000 years would be... 10,000 years, you just take a bunch of spray paint up there. You pay people, they go up and they spray paint it.
So this is radiation pressure approach.
Yeah. And you only have to deflect it a little bit before it doesn't.
So for those who maybe haven't seen that idea or approach, if something is painted white, obviously it deflects more light from its surface, because white is not absorbing that light, or at least it's taking it in and pushing it back. So you could essentially push something with the radiation pressure by getting up there and spray painting it white is the idea that Jason's having. Now, obviously, that's going to take a long time to have any effect, so you need a long time before it's going to reach the Earth. So,
well, but for something that's only 100 meters across, that's like the sweet spot where you get all sorts of weird radiation effects.
So Omnifarious says a gravity tractor is when you hover a spacecraft consistently close to and in the same direction, so the asteroid is pulled towards it. Oh, okay. So essentially putting something close to it and letting gravity do the work. With again, would be a small deflection unless you're putting some massive some massive Death Star up there, and also probably having some sort of anti-gravity device. But again, if you have enough time to do these things, then that makes sense. What would a short-term thing be? Just try and nuke the damn thing.
Yeah, like drill a hole. I mean,
are we on to Armageddon? Is Armageddon a thing, like, or not?
Well, it's certainly the way you wouldn't want to just explode something on the surface. That wouldn't do anything.
Because there's no air to do the pushing, right?
Well, I mean, so you'd have a kinetic change, but like you can get more energy from just a ballistic collision like this than with a nuclear. There's no thrust, right? So, because a collision, that's why you can shoot a little rock at a ballistic missile from, if the North Koreans decide that they're going to launch a missile at Hawaii, you can hit it with a rock. And if the rock is going fast enough, then it'll destroy the missile. I mean, the same reason that gunshots stop people with a large enough caliber.
Science and images will be rolling in soon, so stay tuned to nasa.gov/DART. We'll be back at 8 p.m. with members of the team to capture
I wonder how many frames per second
and celebrate this historic event. So join us soon on nasa.gov/live.
Because it's going at 14,000 miles an hour.
On Artemis and rollback operations happening tonight at the Kennedy Space Center, head to nasa.gov/Artemis-1.
It looks really jumpy to us, but it's probably
Thank you for watching NASA's coverage of DART Impact from Johns Hopkins Applied Physics Laboratory in Maryland. We want to give a special thanks to all of our guests for participating in today's broadcast, and a big shout out to my co-host Samson Rainey for keeping us keyed into the action. Go DART, and good night.
So that looks like that's all we're getting for now. Now I will cover the Lycia cube and the ground-based stuff when that comes along, which I guess is just going to take a little bit of time to get the images down from there and make sure they're sensible for outside consumption, and also obviously it's going to take a little bit of time to understand the rates of the eclipses, the transits that we're seeing from Earth as well. So it's going to take them a little bit of time to do that analysis and tell us what the upshot of what we've seen is. Hopefully we'll get some of those images from Lycia cube, which hopefully show a puff off the surface and what actually happened during the impact. But as and when that happens, I will make sure to cover it. Jason, you were going to say something.
Cool. Oh, I was going to say thanks for having me on.
No, great pleasure. There's a couple more comments. So you want the momentum directed in a direction, so it would have to be a nuclear shaped charge that propelled an impactor or push plate or something. Yes, obviously you need thrust in a particular direction, otherwise you're just losing everything. 1 frame per second, apparently we're told, on the. So
it was a fairly high resolution camera then, because 1 second at 15.
What was it? 14,000 miles per hour or something?
Yeah, 14. Is that like 14,000 meters per second as well?
I don't know
They're almost the same, I think.
Let me have a look.
It's a factor of 2, so it's
14,000.
6,000 meters per second. So that's 6 kilometers per second, or what, 3 miles per second.
So we did pretty well.
So that was taking a picture 3 miles away. That second to last collision was 3 miles away from the surface.
Well, that's very high resolution then, because it looked like it was sat right on top of it. So that was really good.
So maybe, well, I mean, I guess it depends on when in the cadence that frame came up. But anyways.
No, very, very interesting. Any other before we call it a night, because it's 12:30 here. So I should probably get off.
Nothing going on except I guess they're going to turn the LHC off in the wintertime, because we wouldn't want the Belge to leave their nuclear reactor online. It's like, oh, we're heading into winter. We want clean energy. We have this nuclear power plant that produces clean energy.
I know this is one of your major bugbears, is that they keep
how stupidly the Europeans are handling their, especially on the continent.
Yeah, we're not doing the best job. The energy rates here have like doubled over the last month or something stupid. Like the rates have gone up. If you were paying 1,000, you're now paying like 2,000 or 2,500. It's absolutely ridiculous. Another cool thing that Jason and I are working on is potentially looking at how stars look from different exoplanets. So a tiny little heads up about that.
Should be fun to see how that turns out.
Yeah, some very interesting work. Any other closing comments, Jason? If we have an asteroid coming towards us, we talked about gravity tractors, we talked about kinetic impactors. What else have we got? Nukes, maybe not the best. Solar sail?
Well, that's kind of the same thing as radiation pressure.
It is, isn't it? Like land on it, put a big solar sail around it and try and deflect it in that way.
Yeah, so that would make it, then you could get a larger surface area.
Yeah.
If it's rotating, then you can't really do much with it.
No, because then it's going to get all tangled
because it's going to go in all the different directions. But so I think there was something about like shining a laser beam at it. Laser beams those aren't really, you lose a lot of energy. You can at least direct it, right? So laser beams, you can focus and keep the beam going in the right direction, but they're not all that efficient.
So there you're talking about what, another radiation pressure type thing?
Yeah, I mean, radiation pressure is kind of the way to go, I think, with all these things. If you're far enough out, the kinetic impact is enough that, now after 1,000 orbits, it might be in a different spot. So,
of course, you could knock it into, you could start a horrible chaotic react. Yeah.
And the Millennium Falcon then wouldn't be able to get through.
So you can make it much, much worse. Well, I can't think of anything else. Is Armageddon even remotely feasible?
Well, I mean, they were going to blow it up, so I don't think it's feasible to just say like, oh yeah, we're going to just land people on the surface of this thing with all the equipment that they need. That's kind of the.
It seems.
They had to have had a whole lot of fuel on the space.
So like, get behind it, chase it, land on it, and then drill and blow it up before it reaches the Earth, which seems dubious.
If you have 1,000 years, then that's plenty of time.
Well,
they only had a weekend.
Yes, but they had 3 days or something stupid. So yeah. There's
Thanks for having me on.
No, always a pleasure. Thank you for offering your thoughts. No, that was super, super interesting. I really, really enjoyed it. It's a first. The first time we've moved a celestial body, and we'll see
how it turns out.
Yeah, how that's quantified, how that turns out, and how well it would fare in potentially protecting the planet. And I'm also interested in just as we kind of discussed in more detail, getting more of an idea what the hell these things are made of, which is also part of this for modeling purposes and understanding how useful these kinetic impactors would be. So thank you guys for coming by and asking such awesome questions. Jason, thank you again for taking the time. I know you had
talk to you later.
You had your students before, so I appreciate you taking the time. I will send you some plots and stuff tomorrow, and have a good evening, and catch all you guys later.
All right. Bye.
Take it easy. Bye now.